to become? Well, that's nothing but 1 over, so the numerator is 1, the denominator is the square root of cosine squared of theta, which is just cosine of theta. You've got a cosine theta d theta here. I don't want to put it all the way here again, I just leave it on top. So you have cosine of theta d theta. And this for us, luckily, can be simplified to just 1 d theta. Right? It's just the integral of 1 with respect to theta. So what will this be? Hopefully you know, right? It should just be, sorry about that, it should just be equal to theta plus c. The c is something we expect to see because it's the constant of integration. Whether it's here or when we're writing a final answer in x's, we'll always see the constant of integration, right? It's an indefinite integral. But we can't leave it as it is right now, right? We know that we were given a question in x, so it's our obligation to return an answer in terms of x, not in terms of theta. So to do that, we're going to look at this relation here, and we're going to find theta in terms of x. So all we do is take the inverse. So the inverse sine of x is equal to theta, right? And so over here, instead of writing theta, we can just write inverse sine of x. And just say that, we're done. We have the inverse sine of x plus c as our integral for this. There seems to be no commonality between a rational function here and an inverse trigonometric function, but yet there it is with this nice trigonometric substitution. Like I mentioned earlier, you don't have to use x equals sine of theta. You can also do x equals cosine of theta. I encourage you to pause the video, follow the same procedure. I just walked through it here, so just do it. All you have to change is x and dx. Then of course this work will also change, but very slightly so. You won't get exactly this, but you'll get something that you should hopefully recognize from this integral, right? You should get negative inverse cosine of x plus c. And you see that those two are equivalent, right? So hopefully you enjoyed this video, hopefully you learned something new. There are a lot of other places where you use trigonometric substitution, right? It's not always with sine or cosine. It can be with tangent, secant, and things tend to get a lot more complicated, but this is just a good introduction to why it's such a useful mechanism for solving integrals. So I hope you enjoyed the video. Thanks so much for watching. Bye.